Welcome to the Dassault Systems webinar on leveraging analytics and vehicle program intelligence for better results. Today, we're joined by our special guest, Jeffrey Hodel. As Program Director, Product Innovation, Jeff leads IDC Manufacturing Insights research and analysis of the PLM market, including topics such as the development of an innovation platform and the intersection of product design, development, and digital manufacturing. Jeff will present digital transformation and PLM analytics. He'll be followed by Olivier Sapin, Vice President of Transportation and Mobility at Dassault Systems, who will explain why PLM analytics in the automotive industry. Then Morgan Zimmerman, CEO of the Exalead brand, will describe the features of PLM analytics for vehicle program intelligence via a demo. Again, we'll be answering your questions during the Q&A session at the end. And with that, I'll hand it over to Jeff Hodel.
Thanks a lot, Karen. Really appreciate it, and nice to be here with all of you today. So again, I'm Jeff Hodel with IDC Manufacturing Insights. I'm a program director there, and I lead our research around product innovation strategies, which includes PLM and other related technologies. So today, for the agenda, I thought we'd cover the following few areas. I want to start off with some of the overall macro trends driving digital transformation, then go into the need for PLM analytics and why that flows naturally from the digital transformation that's happening across industry. And I'll transition into more automotive-specific market challenges and what's going on there and the need for analytics, and then finish up with what we call at IDC essential guidance. If you are familiar with our reports or any of our presentations, we usually will finish the research or presentation with some guidance that you can take away. And then I'll hand over to Olivier at that point. So let me just build this out. So innovation is digitally transforming, and first and foremost is product and value chain complexity. Increasingly, manufacturers across the industry are participating in complex, extended value chains, and dynamic change due to increasing product complexity, customer demand, and service efficiency across those value chains is typical and means manufacturers need to take a systems engineering approach to product development while tying the product tightly to demand and supply. We refer to this extended view of PLM as the product innovation platform. In a couple of slides, I'll show you our model for that if you're not familiar with it, if you haven't seen it yet. So connected everything, I think that's sort of a good terminology for it because it seems everything is connected these days, right? It's ubiquitous. Products are connected, value chains are connected, supply chains are connected. Customers are more connected to brand owners, so the expectations of speed to market with quality products that can be serviced quickly are higher than ever, meaning manufacturers need a way to collaborate and make sound decisions quickly. Making sense of data. So there's a lot of rich data out there through connected products and connected processes, manufacturing and supply chains that is there for us to take advantage of. So making sense of data is a real challenge here. Manufacturers have a wealth of information across the enterprise, which if managed and analyzed in a unified fashion, can drive product and service innovation. Product quality. We conducted a product and service innovation survey last year, and the top area of focus around product and service is quality. Furthermore, when we asked what their cloud plans are, they said quality is a top process to roll out in the cloud. I think the growth of complex, smarter products that have an increasing amount of software within them not only increases the difficulty of building that product, but also maintaining and servicing it. So move on here and build this out. The convergence of information technology, operations technology, and communications. There are efforts to cultivate greater customer and asset intimacy, and manufacturers are increasingly adding smart functionality to their products. They're adding IoT technologies such as telematics and sensor-based remote monitoring for asset health, diagnostics, and predictive services. Mobility, social product development, production, and service can be the bridge between products, assets, and engineering. So sustainability and compliance. always, at least in the background, as a consideration for manufacturers. Compliance continues to be a driver. If you look at some different industries outside of automotive, heavy equipment has Tier 4 emissions that they have at least met at this point, and there are future compliance regulations that are coming in that industry. There's the Eco Design for Energy Efficiency and Industrial Machinery. There's, of course, ROS, WE, and REACH, which affects the high-tech industry and process industries. And increasingly, manufacturers are paying attention to the energy efficiency of both their product and plant as good business. We saw that in our research from last year. So increased competition in new markets always comes up in our survey as something that keeps executives up at night. Probably most surveys, if you survey a CEO, they're going to talk about that. Global competition remains one of the top things that keeps them thinking about how do they differentiate. From this flows the natural questions of how do I get products to market faster? How do I penetrate new markets that have unique demand and needs? And finally, through all of that, some industries more than others need service, but customers expect increasing levels of service. I mean, if people who sell into the industry, such as industrial equipment, really are looking to service as a way to make money, but of course, customers in every industry expect a high level of service. So those who thrive in the digital economy, we think, will be organizations that can, of course, execute on their vision for digital transformation, whatever that is. It varies depending on what the company is, the size company, the industry they're in, how complex their value chain is. Forge customer loyalty by blending blending the digital with the physical. That is third platform technology such as cloud, mobile, analytics, social business to enhance the experience. Third platform technologies is an IDC term. Leverage information for competitive advantage, we talked about that, and then creating new revenue streams. One opportunity is around connected products and systems, which enable a flow of information about performance and usage of those products that could be leveraged to improve those products, respond more quickly to issues, and even innovate. The underlying theme to all of these is speed of information and decision-making. Products, manufacturing processes, supply chains, demands are all complex and connected with a tremendous amount of information flowing between them. And so companies need the ability to manage, analyze, and consume this information for business value. Enter the opportunity for extending PLM and incorporating product lifecycle analytics. So if I go into what we're calling the next generation of PLM, or the product innovation platform, this is really a new approach to address the digital transformation and complexity, to take a broader view of what PLM can be. So what is the product innovation platform? It's PLM extended to other enterprise systems, data sources, processes, and people for a unified view of all product and value chain information before as well as after market. Talked about the importance of service. We think ultimately this approach leads to product development that is three areas are key, I think. Demand-oriented, data-driven, of course, and then digitally executed. Those three things are really fundamental to remember. Whatever your flavor of the product innovation platform is, this approach you see in front of you here, not every company is going to take this approach and tie to every single system you see on here. There might be pieces of it that they only need to tie to, but it's still a product innovation platform for that particular company. It should be noted that analytics needs to be a key part of every PLM platform, no matter how extended it is. Small companies can benefit by an analytics tool that combines, for example, reporting and analytics on the development process, supplier performance, and product quality information. And I've highlighted in the middle here the core around product lifecycle management, which you see on the left there, product analytics, and you also see systems engineering, which I think is quite tied to enabling good product analytics. So just a quote here from Jeff Immelt of General Electric, highlighting the new reality in today's digital age. Companies succeed over the long term because they change and they transform. GE is a great example of that. Been around a lot of years, and they realize that the complexity and connectedness that exists is driving the need for analytics, so good decisions can be made and companies can grow. So let's talk a little bit about the need for PLM analytics. We'll get into our data. I can't, as an analyst, not show you a few data and survey slides. That wouldn't be right. So first and foremost here, we have a group at IDC that focuses our research efforts on big data and analytics. I'm not the analytics analyst per se, but analytics and big data is obviously a topic that affects every single research area that we cover. And this is a slice of data from a survey they fielded that shows product and service improvement and innovation as a top reason why companies invest in analytics. And we fielded a study last year on product and service innovation practices and plans that further highlights, that I mentioned a couple times, that further highlights the need for analytics to support innovation. And I'll show you a couple of slides here, results from that particular survey. So here goes. One of the key findings here was around quality. We asked two questions in particular for this one. What are the top drivers for your PLM efforts? And what are the top drivers for your SLM or service lifecycle efforts? We really look at those two areas pretty holistically as depicted earlier in the presentation. For PLM, a clear winner was product quality, not surprising when you consider the innovation trends we discussed, such as product complexity, global competition, and the fact that products are more connected. Quality's obviously always been a big issue, but we've seen over the past couple of years, we had a supply chain survey 2 years ago. Product quality even came up in that. I think as manufacturers are looking at supply chain really as part of their product innovation approach and how they get products to market. So definitely a hot topic consideration. And secondly, analytics. We asked what processes does or will your PLM and SLM analytics tools support. From a product standpoint, clearly manufacturers think they need analytics to track, predict, and improve product performance, quality, and service. Also, manufacturing execution was a prevalent response. Why? Because products are complex, and so manufacturing processes are complex. And time to market and demand pressures are great. So tracking and tracing how quickly and efficiently a product is made is critical. So let's talk about the value of PLM analytics. And this may not be, you may be looking at this list saying, well, there are a couple others that you probably could have included there, but I'll just put these up. I kind of ran out of room here, so I'll put these up for discussion. The takeaway here is that there are a lot of opportunities for PLM analytics to bring better decision support across the enterprise. From product quality, again, it's the top reason why manufacturers use PLM, according to our research. So your analytics tool better do a good job at managing this to enable faster service to customers, determine the root cause of quality issues, and then use that information to not only reactively improve and deal with issues, but also innovate those products over time. Then product compliance to monitor and restrict material used in product. Product portfolio management. Manufacturers, I think PPM is no longer only for CPG and consumer products. I think automotive companies could benefit from looking at and are working with some manufacturers out there looking at using product portfolio management. They're going to have, because of the varied portfolios that exist of products, need the ability and they need the ability to optimize variants, product options, and mix. Product costing, the ability to model costs during the front end of innovation based on materials, supplier, manufacturing process, 3PL is an important capability in any PLM analytics tool. And then improved processes. I think this is kind of the where PLM systems have been for years, is being able to provide reporting and analytics on how good your development process is, how your resources are performing, are you meeting your deadlines, and this remains a very important piece of the analytic puzzle here. So let's get into the automotive industry and analytics a little bit here, and then I'll hand over to Olivier in a few slides. First, increasing the efficiency, speed, and flexibility of product development, and we think this can be accomplished by extending their PLM approach into a product innovation platform and connecting related data. Managing vehicle complexity, creating more modular platforms. This is where model-based systems engineering comes in, digital twins comes in, putting the product in the right place. This is where tying to demand comes in. supporting a dealer and service channel so the customer has a good experience from the point when they browse all the way to when they buy, and also into the service part of their experience. And then creating a connected vehicle that customers will value, or making it seamless and non-invasive for customers. That is the flow of information into and out of connected vehicles, and respecting privacy. The whole data privacy issue is important, obviously, here. And then focusing on driver experience, quality and service, obviously, your top areas of focus here. And then getting into the connected car ecosystem. I think this is a really telling slide. You know, it just shows, you know, the expanding connected car ecosystem. There's a lot that OEMs in this industry need to manage while creating and maintaining a good customer experience. Everything from managing information on performance and usage of the car, to collaborating closely with Tier 0 and Tier 1 suppliers that are increasingly design and innovation partners as well, communicating with road and city infrastructure, mitigating concerns about data privacy through regulatory bodies, telematic services, infotainment, and also you know, owner, right? If it's a fleet owner, information about car usage needs to flow back to them. A private owner may want to connect in with their connected home, right? So there's a lot of you know, points of entry of data and information flow that needs to occur here with a new connected car. So, you know, we think organizations in this digital economy need to adapt to changes in their ecosystem by leveraging digital technologies to create customer-centric, digitally enhanced business models. And you can see the 4 areas here that we think they need to focus on. Moving on to another quote here from Mark Fields at Ford, and he realizes that the automotive industry is changing, and so he looks at Ford really as more of an information company now, with the car becoming essentially a you know, high-tech form factor on wheels. And then yeah, I don't know if any of you were at the Consumer Electronics Show in Las Vegas in January, but Brian Kuzanik was there, and Intel was very prevalent. And I just thought it was very telling. I mean, we hear experiences and customer experiences and how we need to design for experience. But I think hearing from the CEO of Intel that customers are choosing experiences over products, right? You know, his clients that he works with, you know, they want him to think about, you know, enabling a better experience in those high-tech products, you know, in those whatever products that Intel is supporting. That's really a consideration even chip makers need to think about these days. And then essential guidance. Let's talk about this just briefly here. Digital transformation and connected products are transforming innovation across the board from product and service. Analytics can be the bridge, connecting your enterprise and value chain, ensuring product and process quality. And I throw process quality in there. I think that's why manufacturing execution came up as a focus area with manufacturers. Are key reasons why analytics are needed in PLM. And in PLM, product analytics are cross-functional here. We talked about all the possible value points in analytics. It's not only engineers, it's not systems engineers, it's the entire collection of people involved with conceiving to designing to engineering to manufacturing to supply, and also servicing that product that we need to think about. And then complex products, demand and supply chains, and relentless competition. We think really the automotive industry is a great opportunity here, and we think we'll see a lot of automotive companies move into this area and can consider analytics as complementing their product development approach. So I'll stop there. That's the end of my presentation, my slides, and hand it over to Olivier from Dassault Systems.
Thank you, Jeff. Let's go on why PLM Analytics is very critical for the transportation and mobility sector. What I would like to introduce right now is, especially I think this topic is critical, and we are also the opportunity to address new roles in automotive company and car makers, suppliers. Especially, I would like to introduce to you the role of car program director. You know, this role is very critical because this guy has really the responsibility of the overall vehicle program end to end, And currently what we see is that there is a shift of responsibility from engineering silos. So when we are talking about such a silos, we are talking about body, interior, chassis, electrical, electronic, software. And somehow we need this guy to get an environment where he can making sure that he can collect every information to actually take responsibility of the complete program. Let's move to the next slide. So if you look at such a role of car program manager today, we have seen that you need to get data for a certain number of people, which are from the engineering department, purchasing department, external suppliers. And we have experienced that in the real life, it's all about information going through emails, phone, Excel spreadsheets, a lot of information that really take time to arrive to the car program director or to any other people in the management team that need those data. And we are really shifting now in our solution from a file-based approach where you exchange back and forth information between the different actors to a platform, a 3D Experience platform that will really get to a single source of data. And it's really about eliminating all the different files. Excel is, sorry, can you come back? I was just hiding. Thank you. So Excel is definitively forbidden. You know, if you really want to have real-time information with all the right information in the platform. And it's really key to make sure that for the car program director, whatever the KPI is looking at, whether it's a business KPI like cost or a technical KPI like weight of the vehicle, he gets the accurate information on a real-time basis. Let's move to the next slide. So for this, we are introducing a new solution experience called Vehicle Program Intelligence, which is really dedicated for the transportation and mobility industry. And it's really about getting real-time status about the project to really reveal the data and making sure that whenever you want to take the right decision, you can visualize this data. You can have all the actors which are taking the right decision to make sure they know the latest status. And it has a lot of value because it makes sure you in terms of, for example, quality, you can really boost the quality of your program because you can really reveal what's going wrong and you can act very quickly to make corrective action. And so you can reduce a lot of risk, you know, along the programs. So it's really a way to accelerate and enhance your business decision. Now, what is going to be in that solution are a different set of process experience. You're going to have a process dedicated for part intelligence to really look at the different parts and products delivered by engineers. Product and component intelligence, whenever it's coming from the bill of material and making sure it meets the actual requirement of the project. And then project intelligence to make sure we look at planning and the end-to-end execution of the project. Change intelligence to make sure we can track and follow all the processes, and you know how much traceability is critical in the automotive industry at the moment. So, and last but not least, quality to make sure that we can follow every kind of indicator, dashboards around quality, whatever it's linked to engineering or manufacturing operation. So now I will hand it over to Morgan so that he can tell us more about that solution.
Okay, hi. So this is Morgan. So let me share my screen. So when it comes to PLM Analytics, let me try to tell you what this is about. It all starts by data coming out from the PLM, but obviously the data coming from the PLM is not enough. It has to be consolidated with data which typically comes from many three letters applications like ERP, CRM, SCM, you name it. Then all of this data, we are assembling it, and then we are repurposing it to be able to understand what's going on from various perspectives. So we want to look at the same data, but understand where we are from a part perspective, from a product perspective, or from a process perspective. The key underlying technological assets that are allowing that, obviously the fact that this is built to support PLM data and the complexity of PLM models. It has complex semantic-based data consolidation, so we can link a part in a BOM with its corresponding cost in an ERP. It is big data, and that's important. Many people don't believe that PLM is big data, but if you start to tackle the complexity of the relationships and you actually want to really handle the relationship between objects within your analytics, then we are quickly talking about tens or hundreds of millions of objects. So it is big data. Computing the weight of a boat with 50 million objects, this is, in 1 second, this is big data technology. It is semantic driven because in PLM we don't manipulate numbers only, we manipulate lots of text, issues, requirements, and it has a sophisticated visualization layer. The interesting question that we've asked ourselves a few years ago is, why is it that when it comes to PLM, most organizations are doing their analytics on Excel or PowerPoint rather than on analytics tools like what they are all doing in the ERP landscape or in the CRM landscape? We actually quickly did get the answer. It's because the traditional analytic technology are not built to support PLM model. Why is that? Because a PLM model is actually a graph. It's a product structure, and it's even worse than that. It's a configurable product structure. On this structure, you have at every node, you have complex workflows that are applied, and at each stages of the workflows, what you are manipulating is statuses, which are not characterized by numbers, but are characterized by statuses, with massive changes over time. If you try to put that into a cube, an Excel spreadsheet, you will see that it's pretty hard to put a graph in an Excel spreadsheet. So this is the reason why traditional cube-based analytic approach just does not work when it comes to PLM. And PLM analytics is all about, can we cross all of these graphs, one after another dynamically in less than 1 second, whether there is 50 million or 100 million relationship, and be capable of understanding where we are from a change perspective, from an issue perspective, or from a resource perspective. We've been showing you many slides, so I'd like to show you an example to illustrate what we mean. This is one typical PLM analytic application that has been built for automotive industry, actually for tracking a cost of a car program. In that case here, what we are tracking is we are tracking the targeted cost for a car program, and we are measuring where we are against that target, and month by month following the evolution. We have named it Gap to Target because we could have named it Margin on Target, but it seems that Gap is a more representative word for the reality of what's happening in a program. What's interesting is this is built on a configurable version of a car program. So if I take a vehicle heading to China, you can actually see that the body is the biggest contributor to the gap, so the biggest source of perturbation in the overall cost of that program. Not only that, but then I can drill down in the product and understand, within all of the subsystems of that car program, what is mostly affecting the price description. So door system, and I can drill down like that up to the smaller subassembly if I actually want to. When I reach to that level, not only I can see for that level what are the evolutions of the costs month by month, but I can even see all of the actual parts that would be embedded in this subsystem, the corresponding cost, the evolution of the costs month by month throughout the iteration with the suppliers, the contribution with the gap, and at this stage I can even go further in the analytic and say, maybe I only want to see the parts that would be unique to this specific configuration within that car program. Most probably this is not the one with the biggest contribution to the perturbation on the cost, but still it gives some interesting value. Not only that, but having done that type of analysis, I'm actually now capable of looking at the actual performances of my supplier. I can look at, for each of my suppliers, which are the most performing or least performing suppliers, and if I select one, for any supplier, I can actually see where I am in my negotiation with the supplier month after month, the material recycling compliance, the history of the contract that are due for expirations, and all of the parts that I'm currently negotiating with what price and what module and what volumes. So I'm using PLM data to empower procurement to drive enhance performance. What I'm showing you here, if I do a little bit of abstraction, is the connection between configured product in a PLM system, ERP and provisioning system with the pricing information, matched together to empower both the program manager, as Olivier did present, as well as empower procurement people to deliver greater performance in procurement to tackle the objective of a specific program.